Hi, everybody. And one of the biggest questions that a lot of people have about counting problems is which technique to use when it comes to identifying whether you should use the fundamental counting principle or if it's a permutation or a combination. So today I'm going to highlight in this video some things for you that are going to help you spot the difference and be able to make an informed decision when it comes to trying to tell the difference between these things. So let's get started. So the biggest thing here is if you have distinct choices to be made, you have several distinct choices to be made, then the fundamental counting principle is always a good technique to use. So if you're at the Frozen Yogurt Palace, you've got this birthday treat coupon that you're ready to cash in for some froyo, and hard to blame you if you wouldn't want that. You've got flavor of frozen yogurt that you're going to pick, 2 candy toppings and a sauce. If there are 8 flavors of frozen yogurt, 12 candy choices, and 3 sauces, how many different ways can you enjoy your treat? Well, because you have distinct choices here, I mean, the yogurt and the candy are distinct from each other and the sauces are distinct from the other 2, then that is something that you can consider when it comes to using fundamental counting principle. So that's probably what I'd use here. I'd probably use the fundamental counting principle to solve this problem. So you've got choices to make here. You've got, the froyo. You've got the candy in the middle, and then the sauce at the end. Okay? And, we're going to come back to this here in a little bit and see if we can solve this. But let's move on for the moment. Okay? If you're picking from a group of similar objects and you're choosing them all at once, so for example, you're dealing like 5 cards off the deck, or choosing a group of classmates to run an errand, or you've got a club and you've got a certain number of people in this club and you need to form a committee for the end of the year party. You need to ask yourself an important question. Does the order matter? Okay? If the objects are similar and repeating is allowed, I would go back to the fundamental counting principle. Okay, so here's what I mean by this. In the previous slide, we had that frozen yogurt example where we had 8 flavors of frozen yogurt, 12 choices of candy, but you could pick 2 of them, and of course 3 sauces. Now, let's talk about this second choice of candy. Come on now, folks. We're going for the double Oreos because it's our birthday, right? We're going for the double Oreos. Don't lie to me. I know that you'd go for it. I would too. So technically, there are 12 choices for that second candy that you can throw onto your frozen yogurt according to your coupon. Now, if repeating wasn't allowed and you had to make a distinct choice of candy, well, then you'd knock it down to 11 if repeating wasn't involved. So that's definitely something to consider. Okay, so let's ask ourselves a question on these problems. Does order matter? How many 4-digit passcodes are possible if no digits are repeated? Well, I'm going to tell you right now, does order matter here? Oh, you bet your life. And since none of the digits are repeated, this is definitely a job for permutations. And you would be having 10 digits from which to select, and you'd pick any 4, and you would not be repeating them at that point. Okay? All right, let's go to the next one here. A light bulb manufacturer selects 3 from a box of 15 for testing. How many ways can the bulbs be selected? Well, does it matter if bulb number 10 gets selected first, second, or third? No, it really doesn't. This is a job for combinations. And you're going to pick 3 from a sample of 3 from 15 in the box. All right, a high school baseball conference contains 8 teams. How many games need to be played so each team plays each other exactly once? Well, the answer here is a little bit more simple than you think. This is going to be combinations because the order doesn't matter. If Waukee has to play Johnston they are not going to have a repeat matchup within this little tournament. So therefore, you'll play each other once, and this works out to be, wait for it, 28 games. So not 28 factorial. Whoops. Okay. How many ways can a manager select 4 of 12 employees for a promotion? Okay, the magic word here is select. Okay, you don't have a specific order in which you want these employees to be promoted. You're just going to select them all at that point. So it's 12, choose 4. It's a combination. And up at the top here of this last panel, how many ways can a manager select 4 of his 12 employees to complete a different job? Aha, now order matters here, because if I am sending an employee to a sales conference, that is vastly different than asking them to head up a new initiative or a project. Those are two substantially different things, and I may want different people in different roles here. So in this case, it is a permutation of 12 taken 4 at a time. So when it comes to fundamental counting principle, remember, if repeating is allowed, or you are dealing with some rather strange ways in which you select items, then that's probably the way you want to go. But if you want to use permutations or combinations, well, if you're looking for that, then the question is, does order matter? If order matters, then it's a permutation. And the key words might be an arrangement, a schedule, an order. It might have to do with some kind of lineup, for example. For a combination, the keywords you're looking for are group, committee, set, sample. Select is another keyword that we bumped into. And that's a quick tutorial on how you can tell the difference in between permutations, combinations, and counting principle. Good luck.